Okay, so we are going to cover our last topic that is in our unit over system of equations, and it is actually a topic over system of inequalities rather than equations. So if you look at this first problem, it says consider the point 1, 2. Is it a solution to the system of inequalities found below? We'll jump down here to this box. The only way we can answer yes or no is by doing one of two things. We can either plug it in, or we can graph. Then, take a look at this note down here. It says system of inequalities cannot be solved using substitution elimination. That's because if you think about substitution, we always want it to be like x equals blah, 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 or y equals blah, 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 right? Well, if we're going to have an inequality, we're never going to know what x or y is actually equal to. So we're not able to use substitution, and really, substitution is a part of elimination. So we can't do either one of those methods with inequalities. All we can do is graph or plug in a point to test it, okay? So to go back to the top, if we wanted to actually answer this question, let's start by plugging it in. So I'm going to take this first equation. 3 times 1 plus 2 times 2 is greater than or equal to negative 2. Well, that'd be 4 plus 4, so 8. It's greater than or equal to negative 2. Yep, looks pretty good. Thinking it's a solution so far. Okay, bottom equation, x plus 2y is less than or equal to 2. 1 plus 4 is 5. 5 is less than or equal to 2. No, it's not. So, is this a solution? I'm going to go ahead and make a guess here and say not a solution. But I'm going to try one more time to prove this using the graph just to double check my answer. Well, you'll remember from when we graphed inequalities the first time that not only do we have to have y equals mx plus b, but we have to have we have to consider the type of line we're going to use, if it's going to be solid or dotted, and where we're going to shade, above or below the line. So let's first change them to y equals mx plus b. Start with this top line. I'm going to move my 3x over. Sorry about my crazy board. Divide by 2. So y is greater than or equal to negative 3 halves x minus 1. So let me go ahead and graph that on board. Minus 1, negative 3 halves, all the way. Okay, I want a solid line because this is less than or equal to, no, greater than or equal to, but the equal to is what I care about. Then because it says y is greater than, I want all these points to go up in the y direction because that's what's going to be greater in the y direction. Y directions are only up or down, so up would be greater. So all of this gets shaded. Okay? So now let's do our other equation. Kind of running out of room here. I'm going to come up here. So I'm going to move my x over. Divide by 2. Y is less than or equal to negative 1 half x plus 1. So I'm going to go graph that. Here's my positive 1, negative 1 half. Oh, whoa, what did I do there? A little off. Okay, and again, a solid line because it's less than or equal to. Now, because it's less than, y is less than, I'm going to again think about the y direction, which is up and down, but I want to go below the line. So that's this way. So really the part that gets double shaded is all this in here. Okay? This is where all of my solutions to this system of equations are going to lie. So if a point is outside of this region, that means it's not a solution, okay? So we're used to looking at a graph and thinking the only point that's important is the intersection. And while that is a solution in this case, that's not the only solution. Anything in this region is good to go. So let's test our point again. It was 1, 2. Well, I've kind of drawn all over this. We can still see 1, 2 is right here where that red dot is. That is outside of that double shaded region, so we are further verifying that it is not a solution. Okay? So, moving on down the page, now we just have a series of graphs where they're wanting us to practice graphing and showing where the solution set is. Okay? For all of them, we're going to have to do y equals mx plus b. For all of them, you're going to find the slope and the intercept like normal, put those on first, then shade. So instead of me making this video ridiculously long, I'm going to pause here and do a lot of the work before we talk through it. So I'm going to put my lines on, but I'll talk through the shading and stuff just because that's a part that I know we still kind of get confused on. So go ahead and pause the video now. I'm going to pause as well, and I'm going to at least start solving for y and putting the lines on the graphs. Pause the video. I know some of you haven't. Okay, so I have all my lines drawn. Now I just need to go back through and shade. And again, I waited to do the shading with y'all because I know that's something that some of y'all still struggle with. So on number 1, the top line I did in red, negative 2x plus 4. And it says that it needs to be less than or equal to. Y is less than or equal to. So each one of these red dots, I need to shade below them to show that it's less than or equal to. Okay? So shade in red below, which ends up over there. The other line I did in green, this one right here, it says that we want y to be greater than or equal to the line. So greater than should be going up this way. So I'm going to shade all in here, okay? And you can tell that the place where we've got green and red shading, little Christmas action here, is in this region right here, okay? So any point that's in that region would be a solution. So for example, if I was to make one up, I could maybe say negative 5, 8, right? Because that'd be negative 5 right here, all the way up to 8 would probably be in the shaded region somewhere, okay? Points that would not work, anything that is just red, just green, or neither out here, okay? I will say points on the line would work. Let me get like a yellow here so you can see it. Okay, so like this point right here, I don't even know what that is, but that point would work because it is like touching the shaded region on a solid line. Now, as we'll see here in a second, the dotted lines change things, but if both lines are solid, then as long as it is in the shaded side on the line, then it's good. So like this yellow dot out here, that won't work. Pretend that's on the line. Even though it's on the line, it's only on one of the lines, so it doesn't work. This yellow dot, or like this one right here, it's not only on the green solid line, but it's also in the red shaded area, so it works either way. Okay, so number 2, the red line is our HOI, the horizontal line going through 3. Notice I did a dotted line since y is less than. So I'm going to shade again down here, less than, most of the graph. The green line, make sure you did yours correctly. This was one where you had to divide by a negative 4, and dividing by a negative is going to flip that inequality symbol around. So I rewrote it down here. Y is greater than 2x minus 3. So that would be up the graph. So I need to shade on that side. So my double shaded region is pretty large on this one. It's all the way from here to here, all in between. Okay? So again, if I'm looking for some coordinates that would work as solutions, anything that's just really obviously in the shaded region would work. But let's talk about the lines. Okay, so for example, if I had this point right here, well, that's on the red line, but the red line is dotted, so that won't work, right? If it was on the green line, again, in the shaded region, but the green line is dotted, so it won't work, okay? Even the intersection, as important as that point is, in other cases, it's not a solution when the lines are dotted, okay? So number 3 was kind of a weird one. You can't really tell, but my 2 lines are graphed here. They really were the same line. They were coinciding. But if you look, their inequalities are different. So the top line was a solid line where y is less than. So that would be down here. The bottom line was y is greater than, and it was dotted. And it's up here, right? Well, if I try to think about anything that's being double shaded, well, obviously there's no region that's double shaded, right? The red and the green squiggles don't overlap. But let's talk about the line itself, right? So for example, the point 1, negative 3 right here. That is on the line, right? So does it work for the first equation? Yes, because it can be equal to. But does it work for the second equation? No, because it's dotted, okay? So the dotted lines kind of always trump the solid lines in the sense that they say, no, sorry, you can't be used because I'm dotted and I don't like points. So This is getting really messy. Maybe beautiful to some of you. Okay, number 4. I did x is greater than a 0. That was a vux. I did that with red. X is greater, so that would be this way, because it's x, so that's side to side. I did my hoy, my y, in green. Y is greater than 0, so that's above. And then last but not least, the blue was that line at the bottom, x plus y is less than or equal to 6, and it's less than, so that's below the line. Lots of colors going on here. So the double shaded region is actually just this little triangle right here. Okay, just that little triangle. Now again, let's talk about solutions. Things that are in that triangle, nice and obvious, those are going to be solutions, right? But let's talk about the edges. Because all 3 of these were just less thans or greater thans, nothing that's on a line is going to work here, because they were all just dotted lines. That won't work, that won't work, that won't work. None of that will work. Only the things that are very obviously inside of those shaded, that shaded triangle. Okay, I'm glad that I paused the video, because graphing those took me a long time, so I'm sure probably took you a long time as well. So number 5 says write the system of inequalities for the graph below. So this time they've given us the graph, they've done the coloring, we're just supposed to write the equations. So let's start with the solid line. Remember, we always write equations as y equals mx plus b. So I need the slope and the y-intercept. So my slope here, it's kind of hard to tell because this is a little grayed out, but it looks like it's just a -1. It looks like everything is going over a box, down a box, over a box, down a box. So -1, or just negative x. Y-intercept, I'm assuming these are counting by 1s. Again, if you're looking at your notes and you're like, no, Mr. Williams, then change it on your paper. But I'm thinking they're counting by 1, so my y-intercept will be 3 when I have my y. Now I'm not going to put equals, because it's actually not equal to, right? This has been shaded up the line, right? There's nothing down here, so I know that it's been shaded above the line. So y has to be greater than, and it's equal to, because it's a solid line. So y is greater than or equal to -x plus 3. So that's the first equation in our system. The next equation, dotted line, okay, y equals mx plus b. So again, I need the slope, I need the y-intercept. Y-intercept's the easy part, that's -3. Slope, it looks like, again, kind of hard to see on the board, but I think it's going up 2 over 1, so it'll be a slope of 2. Then it has also been shaded up, so y is greater than, but not equal to this time because it's a dotted line. So there's our 2 inequalities for that system. Okay? Alrighty, number 6. So this problem actually brings in a situation, which is when we would actually use these things in the real world. So Jamal makes $12 an hour mowing yards and $6 an hour raking leaves. He cannot work more than 15 hours per week. Write and graph the 2 inequalities that Jamal can use to determine how many hours he needs to work at each job if he wants to earn at least $120 per week. So we've been given 2 constraints. He cannot work more than 15 hours. So he needs to work less than or equal to 15 hours. Then we also have been told that he wants to earn at least $120. So we'd want him to be greater than or equal to $120 as far as his earnings are concerned. Well, let's define our variables here. Looking over at our graph, they've kind of done it for us. X-axis is defined as the hours mowing. Y-axis is the hours raking. So if we just combine his hours, x plus y, they need to be less than or equal than that 15-hour limit. If he makes 12 mowing and he makes 6 raking, those together, we're hoping, are greater than or equal than $120. Okay, so let's go ahead and graph these 2 equations. Again, I'm going to pause just to save time. This video is not like 6,000 minutes long, but you go ahead and graph as well. Shade if you can. Notice these are both going to be equal to, so they're solid lines. Shade if you can, and then see what you think about these questions that follow. So I'm going to go ahead and pause my video now. Okay, so hopefully your graph matches mine. What I do want to point out is that I didn't bother shading over in these areas because that would be negative time, and we can't have negative time. He can't mow for -2 hours or rake leaves for -3. So I really just kept everything in quadrant 1, just for purposes of realisticness. That's not a word, but maybe it is. Realistic reality, I don't know. So the black region there is where everything was double shaded. So it says if Jamal decides to mow for 11 hours, what is the maximum number of hours he could rake? Well, you can solve this two different ways. First of all, we know from the story that his limit is 15 hours. So a lot of y'all can just say, well, 4, right? Obviously, that's as much as he could do. But let's look and see how this shows itself on the graph. He decides to mow for 11, right? Here's the 11 line right there. Well, if I follow this line up with my eyes, the top point that I hit before I'm outside of the shaded region is right here at 4, right? So if he's at 11, the highest point we can get is 4. So let's try that theory for the second question. If he decides to rake for 6 hours, what is the minimum number of hours he would need to mow? So raking for 6 would be right here. So if I follow that across, the minimum number of hours he would need to mow would be whatever this is, right? Reading down the page, that would be 7. Okay? It's a little bit harder to answer the minimum questions because you'd have to actually do a little bit of math rather than just looking at that 15-hour limit. Because 6 plus 7 is 13 hours. That's less than the 15 hours maximum that he has, but that's however many hours he would need to work to still make that 120. So again, you want to use that graph to your advantage to kind of look at minimums and maximums, as well as look at all the different possibilities of points he could have. Okay, the last two questions, I'm actually probably not going to finish all the way out, or at least not on video. I may just write them down, again, for time's sake. But I just want to remind you of the very top of this notes page where it says that the only thing that you can use to solve inequalities is graphing and plugging in. So you can't use elimination, you can't use substitution, can't do any of that. So if you look down at number 8, this problem looks great for elimination, right? We could add these together right now to eliminate, it would be beautiful, but we can't because it is not an equation. It is a system of inequalities, okay? So we have to solve by plugging in and graphing. So let's go ahead and just work this problem. So I'm going to plug in 1 and -3. It says prove that it is not a solution. So 1 plus -3 is greater than 2. 1 plus -3 is -2. -2 is not greater than 2. Right off the bat, we have proved that it does not work, okay? But they ask us to prove using 2 methods. So then I would need to change these into y equals mx plus b and graph those on the graph. Notice the second equation, when I change it to y equals mx plus b, I've got this negative here that I need to divide or multiply by. That flips my sign around. Don't forget that. So I'm going to graph these two things over here on my graph. So I've got negative x plus 2. Okay, so there's one graph, and it is greater. Then my other line is 2x minus 1. So here's minus 1. 2x would be up like this. Oh, I did a solid line. This was supposed to be dotted. Let's see if I can make it dotted. Kind of. So this line, I did remember you dotted, and it needs to be greater than. So the only double shaded region is up here. So let's see if our point is in that region. So the point was 1, -3. Go over 1, down 3. That point isn't in any region at all. So that's definitely not a solution. Okay, so the problem right above it, you'd solve it the exact same way. You plug in the point and try it out, graph and try the point, or try the graphing method. I'm going to pause the video. Actually, I'll work out plugging in with you because of these fractions. But then you can graph. Those are pretty easy slopes and y-intercepts, and see if the point works that way. So I'll plug it in with you first. So the first equation, y is less than or equal to -5/2. Oh, I have y. Y is 2. But my x is -4 and minus 2. So now I just work everything out. 2 stays put. -5/2 times -4. Remember, I would always tell y'all in class to watch my finger. It's this 5 times the -4, so that's -20 over 2. That's -10. But really, it was already a negative times a negative, so this is positive 10 minus 2. So 2 is less than or equal to 8. I'd say yes, that is a solution. The same thing with the next one. So y is 2, and then we've got less than -1/2 times the x, which is -4, plus 2. I'm just putting those in. That's plus 2, not 42. Plus 2. So 2 is less than -1/2 of -4. That's just 2. 2 is less than 4. Yep, I would agree. So I would say yes, this is a solution based off of me plugging it in. And then here, let me pause. Okay, so I graphed. I even got a little creative with my colors, which doesn't happen all that often. But anyway, so I graphed my two equations, or inequalities, and now I'm wanting to prove that -4,2 is a solution. So I go put it on the graph, -4,2, right there. And it's definitely in that double shaded region that I highlighted. So it is a solution, both by plugging it in and by graphing. Okay, so moral of the story. When you see an inequality, you cannot substitute, cannot eliminate. You have to either graph or plug in. Thanks for watching.